Okay, hello guys. So this is cycle A phase one, and we're going to be looking at some number sets, which are just collections of numbers. And we're going to, excuse me, be discussing, sorry, the concept of a limit. Okay, so a limit is in the dictionary, in the English dictionary, um, defined as the final, utmost, or furthest boundary. So that's how it's defined in the English dictionary. Um, Mathematically, the mathematical concept of a limit, you can kind of think of it as, this also, but more specifically, when we're looking at a number set, it's going to be the number that we can always get closer to but never pass. Okay, the number that we can always get closer to but never pass when we're looking at numbers within the set. So I'll show you what I mean. So the directions state the first number and the last number for each of the given sets, as well as its lower limit and upper limit. So the set's lower limit and upper limit. If the set does not have a first number or last number, please explain why. Okay, so here's our first number set from -20 to 3, and the brackets mean that we are including the endpoints. Right, so we're including the endpoints and all of the numbers between them. So the first number within this set. So another way of saying the first number would be, I'll say leftmost. Okay, so the leftmost number. What is the leftmost number within this set? It is -20. And then the last number, rightmost. What is the rightmost number in this set? It is 3. Okay, now for the lower limit. So I already wrote this in. So when you're thinking of the lower limit, you want to think of moving left. So moving left within this set, what is the number that we can always get closer to, but we can never pass it? All right, so moving left within the set. So I want to be thinking like we can always get closer to it, but we can never pass it. So let's start at -19. All right, so yeah, I'll think like -19. Yeah, I want a piece of paper actually to show you something. Yeah, let me use this. All right, so you don't, yeah, this you don't have to write down. All right, so here's -20. All right. Now if I start like at -19, let's say like -19 is there. Um, can I get so I'm going to tell you, I'll just tell you what it is. The lower limit is -20 because it's the number that we can always get closer to, but we can never pass it and remain within the set. So at -19, I'm pretty close to -20. Can I get closer? Yes. Let's say right here, like -19.9. All right, so at -19.9, I'm even closer to -20. But can I get even closer to -20? Yes, -19.99. And the lower limit would be the number that we can always get closer to but never pass. Can I get even closer to -20 than -19.99? Yes, you just keep adding on nines. So -19.999. So yes, the lower limit is going to be -20 because we can, moving left within the set, we can always get closer to -20, but we can't pass it. If we pass -20, we're not in the set anymore. Okay, now the upper limit is same idea but moving right. Okay, so this time the upper limit's going to be 3 because I can always get closer to 3 within the set, but I can't pass it and stay in the set. So like 2 is pretty close to 3. 2.9 is even closer. 2.99. 2.999 is even closer. And yeah, so 3. Okay, so here is a case where the first number and the last number are the same as the lower limit and the upper limit. Okay, now let's do this one. All right, so this number set is, -2 is included in it because of the bracket. And then it says negative infinity to -2. So all of these numbers, any number to the left of -2, all the way up and including, all the way up to and including -2 is the set. First number. Guys, there is no first number. It doesn't exist. Because, you know, maybe you think, oh, -100 is the first number. No, because then -1,000, -1,billion, -1 trillion, yeah. So, yeah, there is no first number, so I'll say does not exist. All right, now it said if the set does not have a first number or last number, please explain why. Remember, another way of saying first number is leftmost, and there is no leftmost number in this set because negative infinity means that we keep just going. So I'll say the first number does not exist. The reason why, I'll say I could just be because we can always move further left. We could always move further left within.
Excuse the interruption. May I have your attention, please?
Set.
There are gentlemen in our building today who will be testing the fire alarm.
All right, sorry for the
If
interruption.
the alarms go off, you do not need to evacuate the building. They are just testing the fire alarms today. Thank you.
I gotta finish this before they do that. Yeah, because we can always move further left within the set, so there's no first number, there's no leftmost number. Okay, now the last number is -2. Lower limit. Is there a number that we can always get closer to but never pass? No. Guys, we could pass any number. Like if we're at -100, we could pass it. If we and stay within the set. If we're at -1,000, we could pass it and stay within the set. So there's no lower limit. Does not exist. Upper limit, -2. You could always get closer to it moving right. But you can't pass it. Okay, now this one from 0 to 6. All right, from 0 to 6. 0, this soft parenthesis means we are not including it. So like that. All right, now, what is the first number in this set? Meaning the leftmost number in this set. Okay. Okay, so guys, the leftmost number. So here's 0. Now, 0 is not the first number in this set because 0 is not even included in this set. All right, that's what that open circle means. So we can't say that 0 is the first number. So maybe you say to yourself, okay, well maybe then 0.1 is the first number in this set because I know 0.1 is to the right of 0 and it's pretty close to 0, so maybe it's the first number. So maybe 0.1. I'll say it like right here. So maybe 0.1 is the first number in the set. No, it's not. Because guys, there's infinitely many more numbers between 0 and 0.1. For example, 0.01. But then this isn't the first number even because there's infinitely more numbers between 0 and 0.01. So maybe you say 0.001. No, this is not the first number because we could still keep putting more zeros and we would be to the right of 0. So anyway, there's no first number. So does not exist. I don't know. I guess maybe. Yeah. Okay, I think we could just use the same explanation. All right, because first number means leftmost, and like I'm illustrating here, we could always move further left within the set. since 0 is not included. Yeah, if 0 were included, we could say 0 is the first number because, it would be the leftmost. You couldn't move further left than 0 if it were included. But since it's not, we could always move like further left. Yeah, so I guess I'll just say the same thing. Yeah. Okay, I'll say because 0 isn't included, and I'll say so we can always move further left within the set. Okay, I think that's pretty good. Yeah, this is what I said when I did a dry run. I said because 0 is not in the set, but within the set we can always get closer to 0. That's what I said. But this one is basically the same as the infinity one, so I'll use that. Okay, the last number is 6. It's the rightmost number. Now, the lower limit. All right, the limit is the number that we can always get closer to but never pass. Guys, so the lower limit would be, you think moving left. So moving left within the set, what is the number that we can always get closer to but never pass? Guys, I kind of already illustrated it here. It's 0. You can get as close as you want to 0. 0.1, 0.01, 0.001, 0.0000001. You could always get closer to 0, but we can't pass it. Okay, if we pass it, we wouldn't be in the set anymore. So the lower limit is 0. So here is a case. The first problem, we had the first number and the lower limit were both the same, both -20. Again, for example number 2, they were the same. The first number didn't exist, neither did the lower limit. But here we have a case where the first number doesn't exist, but the lower limit does. Okay, so there isn't a leftmost number, but moving left within the set, there is a number that we can always get closer to but never pass. Okay, and then 6. Alrighty, and now this very last one, guys, you could stop the video here if you want. These notes are provided in the packet, but this is very similar. I'm just, -1, 50, including, not including. Okay, the first number leftmost is -1. Lower limit also -1. Moving left, I can get closer and closer to -1, but I can't pass it and remain within the set. Last number does not exist because 50 is not included. So we can always move further right within the set. Okay, so that's why there's not a last number. And then the upper limit will be 50 because moving right, we can always get closer to 50. Okay, guys, so there it is.